no issues going forward. Okay, next we'll jump into our guest speaker. So I would like to welcome Heidi Frost Eriksen from Winterleap. She is the co-founder and CEO, and it's a Norwegian company. So Heidi, if you want to introduce yourself, and then I'll hand it over to you.
Yeah, thank you, and good morning, everyone, and thank you so much for inviting us. So yeah, I'm Heidi, CEO of Winterleap and one of the co-founders. And I did actually also invite Cornelis to this call, so I'll let him introduce himself after. But super short, we're joining this meeting today because we are very much looking into now do pilots in Canada with our new technology that we're going to share a bit about today, but also in general to just expand our Canadian network. So we're genuinely interested in getting to know all of you. We are a newcomer to Canada, so again, feel free to connect with me on LinkedIn after or reach out. Really, truly like being invited to this network. And I know Cornelius, maybe you want to say a couple of words about yourself.
Hello, all. My name is Cornelis. I'm also the co-founder of Winterleap. I'm the CTO, originally the inventor behind it. My background spans from mechatronics. I've built machines, been in agriculture, and also plant physiology applied, and yeah, science in agronomy. So it's quite diverse, basically.
Cool. So I guess we can just jump into presenting a bit about Winterleap. Let
Yep,
me
that sounds
just,
great.
perfect. Let me just find my presentation here and get it in full screen. So you see it now, right? Yep.
Yep, you're good.
Perfect. All right, so Winterleap, what is that all about? In short, we are solving a very old problem. We help farmers tackle weeds and pests, but we do it during the winter time. And doing it during the winter is actually the key to everything. Today, we see there is a lot of cool technology, new technology coming up, as well as kind of traditional methods for farmers to tackle weeds and pests. But typically, they focus on treating whatever we see on the surface, what is growing this growth season. But that is actually not how nature works when it comes to kind of tackling weeds and on its root cause. So, first thing first, uh, a lot of seeds, as many of you know, they survive in what's called a weed seed bank. Very short, it's an eternal source, making sure nature always gives us weeds. So they can kind of, the seeds can stay in the soil for decades. And every year, a small percentage of that is sprouting. Likewise, a lot of weeds are growing from the root system, so it doesn't really help to remove on the surface. And in addition, we do have a lot of pests like parasites, nematode attacking crop from below. So, long story short, we see farmers treat the same weed or pest problem year after year, multiple times per season. So, for Winterleaf, it is actually all about starting on the root cause and very much focus on what is below the surface. So we strongly believe in kind of moving from more reactive type of treatment to a very like preventive root cause type of thinking. But also, what is maybe one most obvious about us, it also sits in our company name, Winterleap. We are actually moving treatment to wintertime. Okay, this is the most nerdy slide of all, and it's very texty, so I apologize for that. So, but just like to explain a bit, what is this all about? So, what we do is that we use microwaves on frozen soil. And in order to do that, we are actually taking advantage of actually the fact that when water is freezing into ice, the hydrogen bondings are changing. And that makes it possible for microwaves to actually penetrate deep down into the soil. It's almost like it makes the soil level transparent for the microwaves. So by doing that, we get microwaves deep in the soil, and then we very specifically target weeds and pests while in winter dormancy. And the way we do that is by our own software. So we use the software to very specifically steer the microwaves. in terms of what frequencies we are using, if we are pulsing or not, how the depth of it, amplification, also the speed of the tractor is a factor here. But it always starts with the biology, fact components of whatever weed or pest we're targeting. So, for example, we've been able to make some weeds not sprout at all. Others, we've been able to make them sprout too early, but without kind of the protection system, so that they were kind of killed by the sun in the springtime. We have been able to destroy the winter protection kind of layer of some nematode types. And very, very important, and we always being asked this question, is that this is not a technology. We're kind of killing everything on our way. We are not heating the whole soil column, meaning we do preserve all the good bacteria, the soil structure, all the things you want to kind of stay in the soil. And we have done tons of soil sampling and third-party validation to actually be very sure that we are preserving the beneficial soil life. But it is a species by species type of approach. So if you just blast a lot of microwaves in the soil, you wouldn't get any results. So this is very much like a tuning of yeah, as I said, frequencies, depth, pulsing, and very much always starting with the biology of the species. So to sum up a bit, like what are we making? It is a hardware part. What you see on the picture there behind the tractor, it is a prototype that we've been using. Just think inside that one sits a lot of microwave antennas and amplifiers. And then we use our kind of software packages to very specifically treat how those microwaves are behaving. So you could say that a lot of the IP and like the know-how, the very unique thing is actually on the software side. And the list that you see here, this is our bragging list. We have been testing for a couple of years now. So these are the species where we see best result. And like personally, what I think is really, really cool about this is that it's such a wide kind of range of biology. So, for example, the first one, northern root knot nematodes, it is a living organism, a soil worm, like a parasite living deep in the soil. Second one, Canada thistle, it is a deep-rooted perennial, really, really nasty, hard to get rid of. The third one, we were working on the whole seed bank. We also actually have a species called Japanese knotweed. It's an invasive species. We have a lot of it here in New York. We have it in Canada, and not typically a problem for growers. But again, we have seen great result here, and also showing a bit of the promise in the technology that this can, like one hardware, can actually be treated on a kind of huge variety of species. And it is also a crop agnostic type of platform. We don't follow the crop so much more what pests and weeds are we after. And we have file patents in all core markets. So the product, it is a bit of hardware, it's a bit of software, it's a bit of biology, all kind of mashed together. And for the growers, the farmers, couple of things with this is super cool. So feedback we've been getting is maybe the strongest one. When you kind of move the money spent, the time spent on getting rid of nasty weeds and pests from kind of doing it every season many times to kind of start working on the root cause, that gives dramatic reduction over time. So you can think about it like we talk about like a seed bank. Yeah, it is like if we take away 80% of your bank, then next year it's so much less left. And then you reduce that one instead of doing what you do today, which is treating a small percentage of the weeds that keep sprouting every year. So in terms of input cost and margin, this is a very, very strong driver for farmers. The other thing is, of course, working in the winter in season-based agriculture. In the winter, nothing much is happening. There is no pressure on your workforce. There is no crop in the soil, so you don't. This is very, very simple to treat. You have, because of that, a very wide application window. Our only requirement is frozen soil. It is an enabler for the technology, also a requirement. But apart from that, it can be like snow or wind or ice or whatever. But also in terms of soil health, when you drive a tractor and the soil is frozen, you don't risk destroying any of the soil structure. You don't have any soil compaction. Um, and of course, this is an alternative to using herbicides, pesticides. A lot of farmers use tillage to get rid of weeds. It's also an alternative to that. And for Winterleap as a strategy, we always start with the worst species. So we don't plan to position this as a now we compete with your general weed program, but much more starting with those species that really drives the budget. So everything that is kind of living below the surface is by default much more expensive and harder to get rid of, like nematodes or the deep-rooted perennials. But also, we set focus on first now herbicide-resistant species um, that also can give dramatic negative effect for any farmer. We are a Norwegian company, so based in Norway right now. We have been working with this technology very much under the radar since 2020. We used to be part of another ag tech company, a Norwegian one, and everything that is Winterleap today, this was supposed to be a new business line in their company. Unfortunately for them, and maybe good for me and Cornelis, now looking back to me, they couldn't continue, they couldn't raise fund basically. So, so we were able to, after a long negotiation period, buy out everything. But it also means that it has been invested quite a deal of time and money and resources into now doing 3 winters of prototyping and validation. All of that has been done in Norway with Norwegian growers on the field in real farming environment, but also heavily supported by our local ag university and our kind of local extension specialist organizations. And we are now at the time where we have seen good enough results on enough species, but also very importantly, just tested. Does it at all work to use microwaves in the frozen field? I mean, we do operate in the winter, can be really harsh weather. Um, so all of kind of that testing has already been done now. Just to share a bit about some of the results we have seen. So this here was from a farmer growing corn, and we were working on a weed called lady stump, and we were able to reduce the seed bank with 82%, which is a lot because again we are working on like the whole reservoir of seeds here, not just this year's sample. If you see the picture all the way to the left, where it says test and control, you see a bit how we have been working. So smaller fields, we haven't done kind of full field treatments, but more test areas and control areas, and been getting using third-part validation to actually count weeds, both where we treated and where we did not treat it, to see the results. Another trial that we did, this was with a carrot farmer. Here we worked with a nematode. You see that little thing moving there in the picture? That is actually a root knot nematode. It is taken from our microscope video. And in this trial, we were able to reduce the population with 80% one year and 72% the other year. Again, really, really high number. This particular nematode, it infects all root vegetables, but it can also feast out of weeds. And it is very few kind of methods to get rid of it. You can use fumigation. It is legal in Canada and the US. It's not legal in Europe due to toxicity, but it is a very, very hardcore way, an expensive way to get rid of it. This is the grower that we were testing with. Um, at the time, he was losing 50% of his whole carrot crop. So it's dramatic. And unfortunately, he was like a kind of mono farmer only doing carrots. He has since been forced to now do crop rotation. He's trying grapes for wine and corn. But again, he sits on very kind of high quality type of sandy soil, perfect for vegetables. And the kind of economic return on shifting to, for example, corn or wine is just so much less. So it is a really kind of brutal situation. So stage-wise, where are we at right now? So we have been doing, as mentioned, 3 winters of prototyping in Norway. And now we're at the time where we have bought out everything, formed a separate company, Winterleap, and we are currently building the first commercial-ready winter machines. They will be deployed in kind of full-fledged scale in December 2027, so a bit more than a year from now. But in the meantime, we are doing pilots now in the US, Norway, and Canada. We're just think that we build our technology like modular. So we're bringing like a small module only. So we'll do kind of small, small scale pilots. We have already agreed with vegetable growers in Upper New York State, where also Cornell University is going to be part of kind of validating, help us count weeds, do weed validation. So we are going actually now next week, where me and Cornelius are going to New York to visit the growers. Similar, we will continue to do testing in Norway, our kind of test bed and home market. And we also have agreed with a state-funded farm in Connecticut to do some local validation of some nematode species. But also, we are now in conversations with Zone AgTech in Montreal. So we're going there in June to also test for species there. And again, we are now in the process of deciding which one, but it will typically be starting with the worst ones, herbicide resistance ones, perennials, and nematodes. So that is a bit where we're at as a company now, and also why, again, as mentioned, we are kind of new to Canada. So please welcome us and introduce us. And we don't have kind of that network built, but we do see Canada as a super interesting market for us. This slide is actually it's from our investor deck. We show it to all investor also in Europe. Yes, we are a Norwegian company, but we always kind of seen US and Canada as the core commercial market for this type of technology. Everything green on the map is current cropland. Everything that is north of the dark blue line is, yeah, as you guys know, it's where you have long winter and kind of frozen soil for many months, super kind of areas for a technology like Winterleap. But also everything north of the lighter blue line, this is like an area, a belt where you do have frozen soil in the winter, yes, but you also have periods without. It is very much like we have south in Norway. The same thing, like you can have like areas in the middle of the winter where there's actually no frozen soil. But also in this belt, this is typically where you have higher pressure from, especially a lot of the pests, like a lot of nematodes, but also invasive species, tends to come from south and move more north. So you also have a willingness to pay for certain species that is super high. For us, we start with vegetable growers when we are starting now. Reason for that is very much commercial. It has nothing to do with the technology. It is just that any vegetable grower will always face high hand weeding costs. We still haven't met any vegetable growers that doesn't need to do hand weeding. Sometimes during the season, you cannot rely only on chemicals or mechanical removal. So this is kind of we can kind of go up against an existing budget post and provide a cost more cost efficient solution. So it's a good starting point for a new technology. But with that being said, we do see more kind of moving into corn, soybean, other type of markets as equally relevant. So our journey will be a bit starting on the east side and then move west in both countries. And we will kind of scale, always starting with the worst species as mentioned, the ones that are really killing your budget. And I can move on to the next one. These prices are, I would say, temporary. We are experimenting with it and all. But we do believe that when we enter the market, it is smart to have this on a more a rental model that we rent out the winter machine. The farmer is using his or her own tractor and equipment as a service model. We have actually tested this $2,000 per day logic in Norway. We did a test this February. We called a lot of farmers and say, hey, we're going to rent out the machine. It's going to cost $2,000 per day. And within 3 weeks, we were able to sign for $88,000. So for us, it was important to see, is there a willingness to pay? Does farmer really want to pay for this? I mean, I think we've all seen enough for just awesome, cool technology that doesn't go anywhere because it's too expensive or it's not solving a real painful problem. Um, but long story short, we believe in the beginning will be at least first and second winter will be kind of on this model. We will take more of the risk, allow farmers to do small scale testing, just yeah, validate, yes, it works on my species. Moving forward, we will sell this on a more traditional model, sell the hardware, and then we actually have a lot of playfulness when it comes to the software. These prices here, again, not set in stone. We are testing now, talking with farmers, seeing how should we actually bundle and put this together. So some farmers like completely hate anything recurring. So we will for sure have a model where it will be possible to have more than just an upfront type of model and maybe have more extension packages like one-time buys, like you do with a lot of gaming, right? You buy the device and then you add modules. But we are also now experimenting and looking into how can we actually do it on the software side. Because again, remember the hardware. One hardware can cater for a lot of different types of species. So this is also a product that fits really well selling to kind of service companies. For example, doing herbicide as a service in the summertime. This could be like a winter product or service that could be offered. We're all often being asked how much can be covered. And it really depends actually what species, like weeds and pests, we're treating for. For example, I did mention root knot nematode as one species we've tested. It sits deeper in the soil level. We know that we need to treat it with a specific frequency, and also we need to drive slower, typically 0.3 miles per hour, meaning you can treat 2.5 acres per day. We've calculated with 10 hours per day logic here. Whereas a lot of the weed seeds, many of them sit much higher in the soil level, so you can dry much faster. Also can use pulsing for some species, so you can actually treat 10 times as much. So you see there is a bit of range in terms of how much can you treat. And these numbers here is based on what we call like one module, like the on the upper kind of tractor picture, you see like one winter machine, which is what we are building now, the first kind of version of it. But when that being said, we are also building this in a way that it will be possible to have much bigger machines so that you can handle much bigger farmers also. And typically dealing with hardware in the beginning, hardware it is expensive, and then you cost optimize. So the first equipment is always cost you much more. We already know like there's a lot of things we can do to get kind of cost down. You get it down, and then you start building bigger machines. And just a bit about this is numbers coming from farmers. Like what are we kind of in terms of budgets we're being compared with? So, for example, specialty crops like vegetable farmers we always hear that there is a cost for hand weeding. The numbers like there's a huge range in like what is the cost per acre for hand weeding, everything from $400 per acre to 2,000. Someone we all heard also heard like 3 and 4,000 US dollars per acre, whereas Winterleap typically sits at $80 per acre. Here we have been using a logic of a 60-day season. Same with VR. We talked a bit about nematodes. There many of them are. There's not like great ways to get rid of them, but if you use fumigation, which is one for some types, typically a very expensive type of treatment, $3,000-4,000 per acre versus Winterleap 870 US dollar per acre. Again, our treatment per acre is higher because we can treat less depending on speed. When it comes to anything that is kind of deep rooted like perennial weeds, really hard to say what is the cost of that, because for a farmer this is years and years of doing all the stuff you can, from hand weeding to mowing it down to crop rotation to herbicides to whatnot. So typically tends to be high. That's all we get. So just to sum up quickly, we did mention briefly in the beginning about me and Cornelis. We are the co-founders now behind this. We are combining hardcore hardware in very harsh outdoor environment type of experience coming from Cornelis. He has worked in ag tech for 8 years. He's worked previously with soil steaming to get rid of weeds. In the previous company he started, he also built a robot to wash ships while in harbor underwater. So again, software powered hardware in really harsh environments. And he's also affiliated with Plant Science Institute at our local university here in Norway, dealing with ag. Myself, this is the fourth company I'm part of building, and I have also previously scaled Norwegian unique technology, most of all to the US market. So I am a bit new to Canada, but also have worked my whole life with sales, B2B sales, many years in corporate sector, but then now for the last 10 years been part of building companies. So yeah, I guess I'm gonna stop my presentation here and open up for questions.
Perfect. Thank you, Heidi. We'll open it to questions. Dan, you have your hand up first.
Awesome. Can't believe I got first in line. Um, Thank
It
you
was
very much.
close.
That was really awesome. Very cool technology. It's really exciting. So that's first of all that comment. Second, just a question about the mechanism of action. Do you know how the microwaves are doing the damage? Is it thermal or is it the radiation directly?
I guess, Cornelis, that's a question right for you. You are muted.
There,
There you
not now.
Yeah.
Yeah. It's very species dependent. So it's very biology dependent. We know some species, it can't be heat. And other species, yes, definitely. But the energy levels for some species, they are basically too low. It's not a kill mechanism on the spot that
Okay,
we know. And we have some species, they are, well, I can't really tell every mechanism per species, but we specifically go after how they survive winter, basically, which is quite differently between different species.
I see. And in the case where it's thermal, would that affect the speed at which you can operate? So if it's -40, you have to go slower than if it's -10?
Um, you mean the outside temperature?
Yeah, yeah, sorry.
No, it doesn't affect that at all. We work below the soil. It doesn't affect basically anything with the outdoor temperature. If it's -40 or -10, we even have used the system in +8 degrees when the soil still was frozen. So because
Okay.
it keeps frozen even if the air temperature is above.
Very cool. Thank you.
Okay, Ian, you're next.
Thanks. Also very intriguing. Having done a master's degree on yellow nutsedge and the problem with trying to get rid of a perennial by nutlets type of thing, that technology would have been great for that. My question is more on the side of the non-target aspects. Do you have specificity in that, we're working really hard to promote soil biology and all of that, and we don't want to kill all the beneficials in pursuit of the pest ones. So any comments on that?
I can answer that. Yes, I can tell a little bit about my background. I've steamed a lot of soil. That's a temperature process that sort of sterilizes the soil. This was a solution to not sterilize the soil and get the energy levels down and work more specifically. So we have been done since the beginning due to the focus of the soil biology, have taken soil samples all the way. Also, not only sampling, but also microscopy to also validate it, not only like in the labs, like sending it to Eurofins here in Europe. Uh, we have seen that it's more specifically when we began many years ago, we thought it wasn't going to be as specifically as it was, but it was more specific than we thought at that time, which is actually very positive, but it takes a little bit longer time to sort of figure out one species. That's the difference. And if you're an expert on yellow nutsheds, I would really like to have a chat
Sure,
later with
anytime.
you. It's one of the species we want to test that as well. We don't have it here in Norway yet, but yeah.
Yeah, we actually have one of the growers, and also we're gonna go on Cornell's test the farm. We're gonna test for yellow nutsedge this upcoming winter.
Perfect. Cesar, you're next.
Yeah, great presentation, super interesting. And like all these technologies that we get to see, they're all super exciting. And the first thing that comes to my mind is this is too good to be true. So what I always like to ask in this case is do you have any data? And you don't need to tell me right now, and you don't need to show me anything right now. But if you have something, any trials you have done, even if it doesn't have to be a scientific publication, but if you have any trials you have done with growers and you have any hard data, I would love to see it. My field is with science as well now, so that's what I'm most interested about. But if you have anything, and you probably Ashley, you can share my email, and I would love to see it.
Yeah, I'll
Yep,
connect you two over email.
There,
do
I have a
that.
million questions about this. I don't think this is a space to ask all of them. It will be too technical and boring, but I think
No,
Lisa
no,
there's
and
a
no.
I
lot.
work together, so
Please
I
do.
Yeah,
I say data's what we want to see as well.
yeah,
Mhm.
No, but 100%. Obviously, we have like a lot of material on this and all, and happy, of course, to connect offline and go a bit more through this.
yeah, and hopefully maybe we can see one of those in Canada soon.
Okay, perfect. Ian, you
We
have
have
your.
winter.
Just another question when you were showing the reduction in the seed bank, which is, in the old days we could manage that. In the new days, we really have to get rid of that because of the resistance development of the herbicides and stuff. So you
Yep.
had shown a couple of slides there with the percentage reduction in the seed bank. So if I did that 2 or 3 years in a row, I would completely eliminate the seed bank.
Well, I think like no ag tech firm can claim eliminate. I mean, we don't eliminate in nature, right? So, and need it. I mean, you only need one seed to survive, and you'll still have some. So we will never claim anything eliminate, but you would dramatically reduce. And typically, how we kind of recommend for a grower would be like, yeah, treat hard the first season, next season, like get kind of the level down, and then it's just more maintenance after that. But
Uh,
yes, the math is quite compelling when you look at like how can that actually overall over time reduce your seed bank and so I think that is super super exciting part of what we have seen.
Perfect. Brad, you have your hand up next.
Yeah. Hi, Heidi. Yeah, no, it was a great presentation. I've never heard of anything like this before, so it's pretty interesting. Just thinking ahead as you guys work towards commercialization, um, I expect you're going to face a lot of questions as you get up and running about long-term operator safety and the long-term effects on the soil itself. How do you plan to address that when you ramp up your commercial campaign?
I can answer about the safety. We follow the strict regulations regarding it's not like microwaves like damage things. It's electromagnetic radiation we use with different frequencies. Um, we have performed, it was actually very early in the project, also a go, no go regarding safety. We did measurements around the machines, the emissions, and we follow the EU regulations and the FCC for the emissions, and we have always been below those emission levels outwards. The machine will be certified for agriculture use only, with no infrastructure in the ground. But we have technically we are updating it also to sort of detect if there's any infrastructure in the ground. But mostly the majority they don't have it. For the tractor operator, it's completely safe. There's no emissions out from the machine. It's all in the going into the soil.
And Eric put a comment in the chat as well that microwave is non-ionizing. It causes burns, not cancer, as he said.
Yeah. Well, and to that point, I realize there's a lot of people in this room that all understand the difference. But when you're marketing to a general population, they don't. And so you're going to have to work hard to make that distinction and convince people that that's the case.
Yeah.
Yeah, that's actually a good point.
Correct. Dr. Rennie, you have your hand up next.
Yes, I just have a follow-up question like what Brad had just mentioned, microwave heating being dielectric heating. And Heidi, thank you for the presentation and giving the brief and demystifying the technology the simplest way and exploring its application. So you mentioned your price model depends on the type of target you're looking for, and it's basically based on what moisture the target may have and the biological tissue structure. So how you I know maybe it's your IP protected info. You don't have to answer if it is the case. You have a uh, selective technique to detect what power for what microorganism or what biological tissue, or are you using microwave technology for just treatment and also for imaging?
Well, there is no start with the last. There's no imaging because we are working under the soil in when it's frozen. So our technology is blind, so to see. There's no camera or so to speak. Um, but yeah, we might, like Cornelius mentioned, might be able to also now see reflections in the soil. So kind of been mapping the soil. So that is another way of seeing. Um, so the way the treatment work is that before this is not like on a go type of treating. It's like we work prior to a software package to be released. We have already discovered the recipe, so to speak. So it's not like a drive over a field and the technology treats whatever it thinks is in the soil. It's much more we are treating for this species or this species, and also for the farmer. I mean, like every farmer know if you have one of those like really really hard pressure for one species, you always know about it, right? So and typically that's how we start. So it's not if that was a clear, it's not like on the fly detecting now what we see in the soil
Exactly.
and what are we treating,
Okay.
but much more today we know we have Canada Thistle issue, for example, we treat for that and something
Okay.
else.
And the power will be preset based on what we are targeting.
Yes.
Perfect. Thank you so much.
Great, thank you. Any other questions for Heidi or Cornelius? We do have a couple comments in the chat. Heidi, Kate sent you a direct message about mining construction development sites that have issues with Japanese knotwood control. So feel free to, connect directly with Kate on that.
Oh yeah, thank you, Kate. Actually, we are already in contact with Grand Farm. We're actually going there in June to sit on a panel talking about invasive species. They really, really would like us to test there as well. So that's another great place to be connected with.
Well, that's great
Thank
because
you.
they're looking for detection and destruction. They use the word weed destruction, which is kind of curious, but you literally are in that field. So that's great that you're in touch with them.
Yeah.
Janice, you have your hand up next? Oh, you're just on mute.
There we go. I had to click it a few times, I guess. Yeah, I was wondering if there's two pests in the same field, like root knot nematode and a challenging perennial weed or a weed with resistance. Does that mean you need two passes, or can you have some of the microwaves doing one recipe and some doing the other recipe on one pass?
Yeah, great question. I would say now initially we have focused on actually just species by species, but this is more of a very solvable technical question up the road, like how do we combine and how will we put packages together? But the honest answer right now is like we only focus on like this species, this.
Right, right.
So right
Yeah,
now it's a one by one. But yeah, but it's again we are like there's a lot of software in what we do and how we're steering everything, and also we've just chosen not to focus on that right now because
that makes sense.
just young companies, you just need to in the beginning don't overcomplicate too many things at the same time.
Oh yeah, for sure. I have a second question. since you have a specific sort of recipe that targets, like, say, the protective structure on the nematode, then perhaps the nematodes that that doesn't affect with it, like that you will get resistance developing to that recipe. Will you be able to create like two different recipes that both affect that structure so that you can alternate them as a way of resistance management in microwave technology?
I can try and answer it. It's well, currently we have one recipe for one species, how it then functions. We haven't looked at multiple methods. We have seen that some species, let's say if we looked at soil-borne pests like nematodes, that one recipe works on one species. If you apply that recipe to the other species, it doesn't work, and vice versa. So it's your question is to have two different methods of action, basically, to
Right,
avoid
right.
resistance. I think we just focus right now on one recipe and get that going first. And uh, I don't know how many years resistant buildup will happen, but it can take a long time depending on the evolution of and the species, of course, and of course what it is we are targeting on the species. If it, well,
Mhm.
yeah,
Yeah. Yeah.
uh,
Okay.
yeah, that's my best answer to that question.
Oh yeah, no, that's good. I was just curious, and that would definitely be a future problem. But I just wondered, yeah, I was curious about the technical possibility. Thank you.
Thanks. Ian?
Janice's question does raise an intriguing other question, though. If I'm a farmer, am I going to pay that amount of money to go after one species? Yes, if it's a real problem, perennial species or herbicide resistance or whatever. But really, from a weed seed bank management, I would want to get everything that's in there. And so I think you need to sort of put that in your long-term thinking in terms of a saleable thing that attacks all wheat seeds within that top, 2 centimeters would be amazing type of thing. Having to go over that each time to go after individual species, that's going to be a much tougher sale.
No, 100%. And as we kind of continue now to test and put new software packages on the machine, we start with all the worst one, but we will also, test for others. So it is a library that will be growing. Because obviously after 5 years, like okay, there is that one really, really nasty weed, I got rid of it, but then I have all the other ones also annoying, right? So that is a bit of the plan that, same hardware, you can just like update it with new packages. So we're gonna be testing like crazy in like every year, and we also can develop this treatment packages outside winter season for some species, especially weeds.
And having that, it would help me promote less depth of tillage, keep weed seeds close to the surface so that you could run faster because you didn't need to penetrate deeper to get those. Because right now they mix it up in whatever depth they till, and that's problematic for many reasons in weed control.
Mm.
Perfect. Any other questions? Okay, so we'll end the questions there. Thank you, Heidi and Cornelius, for coming onto our call and presenting your technology. I'll connect you directly with Caesar, and I'll also connect you with Matt from the Niagara region. He hosted Innovate Norway recently, so he's interested in connecting with you as well. So I'll send you some emails after this meeting.
Perfect, great. And I can also, if you want to share my LinkedIn here,
Yes.
in the chat, so it becomes part of that. And yeah, again, please feel free to connect with us and all. We are generally interested in building our network with you guys.
Perfect. Thank you.
Here is my LinkedIn.
So feel free to connect with Heidi, and if you have any questions for her afterwards, feel free to send those to her as well. So next on the agenda is we don't have any project updates this week. So just a reminder of some events coming up. I don't know if anybody in this group was at Agri Tech Venture Forum this week and wants to kind of share some insights for the group.
Well, we were there, but I guess we were there to fundraise, so I don't know if
No, that's perfect. That's a reason. So do you want to maybe talk a little bit about the event and like how it was for you as a tech company there?
Yeah, so and again, man, keep in mind we are like a bit of an outsider, right? This is almost a
Hmm.
bit like serendipity, right? Going there, not knowing so many or almost anyone. But no, I think like in terms of it is like it's not such a big conference, right? A couple of hundred participants. A lot of the people there know each other, like all the VCs in the room know each other. So it is a very, very nice place to kind of connect since it's over 2 day and like there's social events like first night and all of that. So we, at least we experienced in terms of racing and not knowing many, it's very good when the conference is not so big because then people actually introduce you and say, hey, that gentleman over there in that blue sweater and like, let me introduce you. So you are like very much, it's a kind of condensed area. So but I also think I've been to a couple of these like yeah tech venture where you have VCs and startups and scale ups and whatnot. And for example, I was in San Francisco before Easter, and I think this one here in particular was good was that they also brought growers to the stage because that I think that is like very surprising in many of these conferences is like only the startups and the investors and maybe some yeah more the strategic or OEMs and you kind of lack the most important person in the room. So I think that is like really good about that event. And and yeah, just in general, very well organized and all. Terrible app, as is always on these platforms. That is like the app that is like confusing everyone with meetings and whatnot. But it's still same message being conveyed. It's very dark, negative in terms of funding. Startups, scale-ups striving to raise money was a lot of the messaging. VCs striving to re-raise new funds takes more time, so there is less capital being deployed. It is a problem, of course, in the industry. We hear actually the same coming from Norway. We hear very much the same message as we hear in Norway as in Canada in terms of there is not enough capital, and everybody tends to point to kind of US as kind of that's where you have to go to raise. But yeah, I don't know. I'm sorry. I come with a very like
Sure.
fun thing in
No,
event. So I
that's
guess
a great
all the other
recap.
good.
Perfect. No, thank you for sharing that. A couple other events coming up, which are demo days to add to people's calendars. I announced last week our working group demo day at Simcoe Research Station on July 21st. So we'll be starting registration for that shortly. Planning is well under the way for it. So save the date, July 21st. Innovation Farms Ontario will be having their demo day in Bothwell on August 18th. And then Great Lakes Tech Flex is also coming up on September 10th and 11th. So again, save the date and reach out to, I think, Mark, if you have questions on that one. Because they're trying to bring together not just US versus Canada, but the whole Great Lakes region as well. So I think that's the end of our agenda. Is there anything that people had issues with or looking for a connection on that this group can help with? Okay, perfect. Kate, I saw that you announced a new project with bats. Did you want to maybe talk to this group about that a bit?
Hi, yes. An ecologist called Sam Watson. He is an ecologist that looks at bats specifically. So he had a lot of trouble monitoring how these bats were coming out of buildings and coming out of chimneys. And he was trying to use RGB computer vision in addition to thermal. And he's having a lot of trouble tracking which bat was in the frame at any one point in time, and then keeping track of which bat was where in very dark and terrible conditions for computer vision. And so we've been working with him to develop a system to be able to track those bats and monitor them. And it's been very successful. And he's very pleased with the system. It takes up a lot of data storage and a lot of compute. So we're looking to help reduce those costs and those processing parts for him. But yeah, very exciting. So if you know of anyone that needs bat monitoring, or we can take that to birds as well, then reach out to Saiwa and we can certainly look at a custom solution for you. Thank you so much for that, Ashley.
No problem. And again, if anybody has like new projects like that they want to like take 30, 60 seconds to talk about, this is the time to kind of do it as well. I just happened to see your post on LinkedIn, so I wanted to share with the group as well. Anything else that anybody wanted to discuss or had any questions about? Okay, I'll take the silence as no, nothing else to discuss. Ian, I saw you came on camera. Did you have anything else to add?
I'll just say that yesterday, I think it was yesterday, losing track of time, I was down with Mark Richards at Dresden, riding in the Fendt tractor with the strip tiller while his roboti was planting corn beside him. And that was a pretty neat experience to see that type of thing operating, doing its own headland management, doing its own everything. Again, the biggest thing that's intriguing about it is the logistics. Okay, so you fill it for 2.5 hours versus seeds. So you got to come back and fill that up. And so how do you make the use of the person that's engaged in that piece as well? So again, it's not just the piece of the technology, which is exciting as all get out, but it's figuring out all the logistics around making the thing efficient and effective. And so it was fun and educational to sit on that tractor yesterday.
Yeah, no, that sounds like a great way to spend a day out on the farm there. Perfect. So I think we will probably close out a couple minutes early. We're almost at time. So thank you everybody for joining today. Next week we have Elise Bigley from CAPI presenting the phase 2 of their digital framework. So make sure to join next Friday as well, because that'll be an interesting discussion. She did speak at our in-person meeting in March, and this is the second part of the framework that just got announced this week that she'll be presenting. So hope everybody has a great weekend, and we will see everybody next Friday. Thank you.